Well, hello there, calculus students. This is to go through the Unit 4, Day 5 Delta Math assignment, where it's talking about increasing and decreasing along with concavity. So I'd like to go through an example problem with you. As you can see on your screen, it gives you the function and it wants to know where this function is both increasing, that would be where the first derivative is greater than or equal to 0 in terms of delta math, and concave up, which means the second derivative is greater than 0. It is important to remember that in delta math, for increasing and decreasing, they include critical points unless they are undefined by a vertical asymptote. And concavity is not inclusive. The AP exam would follow the same thing. So first, I would use the power rule with 3x squared plus 18x plus 15. And I would set this equal to 0. Okay, remember critical points are where the first derivative is 0 or undefined. It needs to be a fraction to be undefined. It's my habit, if I can get rid of the number in front of the x squared, to do so. So I divided everything by 3. You're more than welcome to do GCF if you would like. And I can factor this. The two numbers that add to 6 and multiply to 5 are 5 and 1. So on my first derivative number line, I would have -5 and -1. You're welcome to test points either here, here, or here. That should have been here in factored form. Okay. And again, I'm trying to convince you to save time. If this is a parabola like so, it'll go from positive y values to the left of -5, negative y values in between -5 and -1, and then positive y values again, because we know that parabola is opening up, which you're more than welcome to plug in. So right now, it looks like -infinity to -5. Again, delta math includes right there, would be increasing, or -1 to positive infinity. Just as a little recap, this would be a relative min, or max, excuse me, where we go from increasing to decreasing, and then where we go from decreasing to increasing would be a relative min. All right. So now I need the second derivative. Again, using the power rule would give me 6x plus 18. The critical points of that would be solving where 6x plus 18 is 0. And that would happen at -3. So I can plug in a number smaller than -3. I like to use -10 if I can't use -1. -60 plus 18 is negative. Something bigger than -3, I would use 0. 6 times 0 plus 18 is positive 18. So here we're going from concave down to concave up, which makes this a point of inflection because concavity changes. And we want to know where it's concave up. So this is concave up from -3 to infinity. Okay. But because we're trying to do both, okay, if I was to link this right here, -3 is right here, okay? So if I connect to this section is decreasing and concave up. So my final answer would be -1 to infinity. If you are curious what that looks graphically, here we said we were increasing from -infinity to -5 and then -1 to 5. So there's a point of inflection at 3 where it changes from concave down to concave up. Where is it concave up and increasing? From -1 to infinity. Don't forget to like and subscribe to this video.